Welcome back to the channel, everybody. Like the title alluded to, I think in the modern day, with the advent of AI and what it's capable of doing, trying to find a mentor is in many ways a waste of time. Not to say that mentorship is not valuable, but that you can do it in a much more efficient and cost-effective way by building it yourself. So in this video, that is exactly what I'm going to break down, how you can build your own AI philosophy and life advice companion using only n8n, Pinecone, and a Google Drive. But there's one thing that I want to say. Genuinely new ideas don't come around that often. At this point, we have the wisdom of thousands of years of documented human existence at our fingertips. And in recent years, a lot of people have been flocking back to those ancient wisdoms. You see this in the rise, for example, of the modern day Stoic philosophy movement, where people are finding real meaning in what people said a really long time ago. So instead of sitting there and being sad that you don't have Ryan Holiday or David Goggins or Socrates as somebody you can talk to, let's just build their brain and then have a conversation with it. So that's what I'm going to show you how to do in this video. I built an AI agent, which I'm about to walk you through, that does two things. Number one, it pulls ideas from specific people, such as Aristotle, the Stoics, Marcus Aurelius, Jeff Bezos, Naval Ravikant, and trains an AI database on their body of information. The second piece is specific frameworks, meaning mental models and ways of thinking about solving problems. These were trained on common mental models as taught by people like Charlie Munger, Farnham Street, and other books that I find valuable when it comes to how to think about problems the right way. And so now I'm going to break this all down for you so that you can learn to build your own. So here is a little preview inside of our finished product in n8n, where we can see the types of outputs that we're going to get from this system, okay? And so inside of here, inside of the n8n chat, we're saying, I can't stick to my fitness routine. Help me be hard. Like David Goggins, stay hard. And so the AI asks us more about that situation that we're in. Say, hey, can you be a little bit more specific about that? Are there specific situations where you weren't able to stick to your fitness routine? And then I come in and I say, I keep telling myself I'm gonna work out for an hour, and then I stop randomly after 30 minutes. I don't know why I keep setting myself up for failure like this. Then the AI goes out, it thinks about it, and then based on that body of knowledge that we trained it on, it says, here are some philosophical perspectives on that problem, and here are some mental models that might be helpful for you in solving that problem. So let's look at some of these outputs. So Aristotle's virtue ethics. Aristotle argued that achieving good habits is essential. He emphasized the importance of moderation and building character through consistent practice. In your case, instead of focusing solely on the hour goal, it might be beneficial to concentrate on the quality of your workout and the habit of starting. Consider setting a shorter, more manageable goal initially and gradually extend the duration as you build the habit. Really, I think really good feedback, really practical, good feedback. A lot of us, we set goals in our lives that aren't actually practical for one reason or another. And if we were only to make it a little bit more manageable in the beginning, we'd have a much higher likelihood of sticking to that over a long period of time. What might Stoicism say about this? Stoic philosophy encourages acceptance of what we can't control and focus on our reactions to situations. Reflect on your feelings during and after your workout. If you find yourself stopping, ask why. Are you tired? Are you distracted? Are you not motivated? Like, why are you actually doing that? Acknowledging those feelings without judgment can help you strengthen your resolve and blah, blah, blah. And then a few other ideas. Now, when it comes to mental models, how can we think about solving that problem, right? What are other ways outside of reflecting on what an ancient might have said about it? How can we practically go about solving this problem? It gave some awesome mental models that talked about how we could deconstruct a problem into its fundamental parts and then work on each of those parts individually and then reason from the ground up, right? Instead of just being stuck up here in our problems and feeling anxious about them. So what mental models might help in this situation? The 2-minute rule. This model suggests that if you're struggling to start a task, commit to just 2 minutes of it. Apply this to your workouts by telling yourself you only need to work out for 2 minutes. You might find that once you start, it's easier to continue beyond that initial commitment. So we could take this idea of the 2-minute rule. It's not that it has to be 2 minutes, but again, in this case where we did 30 minutes, it's like, okay, my only promise to myself tomorrow is that it's gonna be at least 32 minutes. I'm not stopping at 30, I'm going to at least 32. Again, practical real life example, I did this in my running routine. So I'm trying to work up to a half marathon, and I was starting to peter out after about 2 to 3 miles. And this was an example of exactly what I did, where I said, okay, well, I'm not going to tell myself that I have to hit 4 miles today, but if I did 2 miles yesterday, I'm at least going to do 2.5 miles today, even if I need to walk that remaining half mile. So practical little pieces of advice. The FOG behavior model states that behavior happens when motivation, ability, and prompt converge. Examine your workout motivation. Maybe you need to increase your enjoyment during the workouts or find a better time that fits your schedule, right? So maybe it's not actually about you. Maybe it's about how you're not setting yourself up for success in that situation. Loss aversion. This model conveys that people are more motivated by fear of loss than by gain. Instead of thinking about just the gains like improved fitness, consider what you're losing by not completing the workout, such as your health or progress towards your goals. Keeping loss in mind can be a practical motivator. And then it gives you a synthesis of all of that into some practical advice. And so again, you can use this for anything, and you can train it on anything. And that's what we're going to get into right now. So the first piece of this puzzle, or the first piece of this process, shall I say, is that we need to get our information into the database, okay? So for anybody that's not an AI super pro, I'll explain to you very quickly, high level, of how like an AI database works and why it works in this situation specifically. So you'll see over on this far right-hand side, this thing that says Pinecone Vector Store. So we're going to show you how to configure all of this, but let's talk about the theory of this for a second. AI models, when it comes to like chatting with a model or having a model that can use your information, works on something called vector storage. There's a lot of math behind how it works, which doesn't really matter. But basically what we're doing is we're converting a document into a format that the AI can understand what's in that document. The way that it does that is by converting your document into a string of numbers. And then based on what you say to it, like, hey, I'm struggling with X, Y, and Z, and I need help with it. Can you help me? It can understand the meaning of what you're asking, convert that to its mathematical numbers, and then it can reference what that you have in your body of information in your database matches that best. And then it returns those passages out of your book, and it can use that in order to answer you. Okay, so let's get into what that actually looks like. First piece is that we need to get, again, the information into this AI database. And so the way that we do that in this example is just by simply connecting a Google Drive. Now I have a video that shows you how to authenticate your Google account. I'm not going to do that right now because not the point of this video, but you can check out the video that I have if you would like that. So in this basic use case, what we're looking for are two things. So I have a mental model folder, right? Mental models, which I have a big book in here about mental models. And then I have a philosophy folder, which are different books from different philosophers. So we have Seneca, Epictetus, and Marcus Aurelius. We have all of their stuff in these folders, and we're telling the system, anytime I add a file into one of those folders, you got to store it in the database. So how does it do that? We're going to walk through that high level, and then I'm going to go back and actually show you how each part works. So Google Drive sees that something got added to it. Cool. Downloads the file, which in this case is a PDF, extracts the text out of the PDF, right? So it can read all the content that's in there. It then stores it in the vector database. Now you'll see here, we have this embeddings thing. You don't need to worry about that right this second. And then we have our document loader. So what this is doing is it's taking the PDF and it is breaking it down into smaller chunks. We don't just store the entire PDF, right? Like into one row. If you were to think of it like an Excel sheet, we're not just adding one row that just has all of the content of that PDF in there, right? That wouldn't really work. What we're doing is we're splitting it up into different chunks, and then we're storing each chunk into the database. That's what this does. So file gets added, we download the file, we split it up into a bunch of chunks, in this case, like 600 chunks, and then we insert all of those chunks into the database. That's the first piece. A lot of technical stuff that goes on behind the scenes with how Pinecone works and all of those things that make it so that the AI can read it doesn't really matter for what we're doing. So let's look at how this actually works. I'm going to show you just the mental model trigger for now. So again, we're connecting to our Google Drive account that has this folder in here, right? Mental model folder. And polling time, we're just saying, hey, every minute, go check to see if there's a new file. You could change. And then it's saying, I want you to trigger. So I want you to like run this whenever a change happens to a folder. What is the change? Well, look at this folder, mental models, which again is just this folder. Look at this folder and tell me anytime a file gets created in it. Pretty simple. We can say fetch test, and it's finding the last time this happened, right? So it's got one of my PDFs in here, and it's the 100 mental models PDF, which I showed you earlier. This one. So it just found when I added that in there. And it's like, okay, I found it. Cool. Now we have another one down here that literally does the same exact thing, but it does it for the philosophy folder. So it's like, hey, watch the philosophy folder for any time a new PDF gets added in there. Pretty simple. If you wanted to add a third one in here, you just go duplicate, drag it down, drag it up here so it's going into this, right? Because everything needs to run through this edit field node. So you just connect it up there. Again, really simple drag, just like this, boom. And then go in here and you would connect it to your new folder. Let's just say for this example, I wanted it to connect to my recipes folder. Just type in recipes, boom. There we go. Now it's there, okay? So pretty straightforward. I'm gonna delete this because I don't want the recipe folder in here. Then it does a few like data cleaning, I guess you could call it, where it's gonna pull the file ID. Okay, so all Google Drive files, just for your context, have an ID. You can actually see it up here. This is the folder ID, actually, but each of these files also has an ID in it. So it's pulling what that ID is, okay? So it's just saying, okay, which file got updated? This is saying it's this file, pulling the ID, okay? Passes that ID to the download function, okay? So it's saying, hey, go download the file with this ID. Pretty straightforward. So we're connecting to our Google Drive account. We're saying, hey, it's a file that we're looking at and we want to download it. And then this is the file. Okay, so we pass that file ID in and say download it. And by the way, if you're like very new to n8n and don't really know how it works, the way you get this in here is you literally just drag this. Boop, boop, drop it in. Now it's downloaded our PDF. Now that it's downloaded the PDF, we need to say, I need you to pull all the text out of it though. So it's going to go through here. If we look at the extract from PDF, you literally don't have to even do anything with this one, by the way. You just say extract from PDF and leave everything as is. And then here we go. It has now extracted the entire ebook or the entire PDF, right? With all the mental models in it. Boom. Plopped right in there. Cool. Now we run one more edit field. The only thing we're doing here, if we were to look at this, I don't want to like pass into my vector database everything, right? Because there's a lot of other stuff about this PDF that isn't necessarily something that I care about, right? So I don't care about the language or is linearized false. I don't care about any of that. So I'm just telling you, I want you to pull off the text field, which is right here, and the author field, which is right here. Just pull those two in and then pass it forward. And so that's what it does. Okay, and we can see two items because it took the text and it took the author and it passed it to the next stage. So now we get into the Pinecone vector store. So if I hit play on this one, you're going to see it go out and do a few different things where it's popping around. As soon as this is done, we will talk about what each of these is actually doing. Okay, so it went through and you can see it did 643 items. You see up here, 643 items. That means it went through and it split that PDF into 643 different pieces and stored each piece into our database. Stored each piece into the database. The reason it does that is that it can find, when I ask a question, which we're going to get to in the next stage, it's going to be able to find the pieces that best match what the user is asking. That's the reason we do that. If we click in here, we can look at what is going on. So we're connecting our Pinecone account, which I have videos that show you how to do this. It's pretty straightforward. You're going to connect your Pinecone account. You're going to say, hey, we're trying to insert a document. And then the Pinecone index, mental models. What does that mean? Let's go actually just look at it. Okay, so we're inside of my Pinecone account. And I have this mental models index, it's called. So this is where all of my mental models get stored. So if I was to click in here now, you'd be able to see where all of the different chunks of the text are being stored into this thing. Okay, they're all being stored into this thing. The reason you see some of them twice is I accidentally added this one in twice. And so we said it was 600 something chunks. Well, I processed this thing 2 times, and so that's why it's 1200 roughly. But it's telling me, okay, we have 1200 chunks in here. It's using the embedding model, text embedding 3 small, which we'll get to in a second. That is important to note, the embedding model that it's using. If you need to connect your account, you can just come to the API keys section and create an API key and then just paste it over. Again, I'm not going to show you how to do that right now because it is pretty straightforward. So after you go in, create new credential, you put your API key in there. Now you're connected. You say, hey, I want to insert documents. And then it's going to ask you for your index. You're picking out what the name of your database is, your index, right? So mental models is the one that I'm looking for because that's where I store my mental models. Now, what are these other pieces doing? So the first one is anytime you store something into a vector database, which is what we're doing here, you can see how it has these 2 nodes flying off it. One says embedding, one says document. You always have to have an embedding. So what that is it's telling the system what exact means of doing that math, right? We talked about earlier how it does all this math stuff that you don't need to know about. Well, it's telling it like what version of that type of math to do, basically. And so you'll remember when we looked over here, text embedding 3 small, text embedding 3 small. These have to match or else it's not going to be able to find and query stuff for you the right way, right? If you were to store it with 3 small, but then when you go to query it later to ask for the information back and it's 3 large, or it's some other random model from a different company, you're not going to get good results. So we're telling it how to do the embedding, how to store it, and then we're telling it how to load the documents in, right? So we have this PDF over here with all these different chunks, just broken into 600 chunks. Let's talk about how it actually gets broken down. So we're saying default data loader, you don't need to worry about this. And then every data loader needs to have a way to split the text up, right? So if you were to think about a PDF, I mean, shit, there's a ton of ways I could split a PDF up. I could look for every time there's a new paragraph, every time a new sentence starts, every time a comma is used, every 5 pages, right? There's a lot of different ways that I could think about splitting up a PDF. And so the one that we are using is called a recursive character splitter. If I was to just disconnect that for a second and click on text splitter, a lot of different ways you could do it. So you can just do a non-recursive character splitter. Doesn't really matter for purposes of this video, really, what the difference is between these two. Or you could say a token splitter, which is like where I said every comma, I want to split it, for example. A lot of different ways you could split a document up. But again, we're using a recursive character splitter. And then the last important thing to note here, we say chunk size 1000, chunk overlap 200. What that means is every 1000 characters, it chunks it, right? Creates a new block. But then there's a 200 character overlap between each chunk. And the reason you do that is imagine if you get to the 10,000th character and you're in the middle of a sentence and the back half of that sentence is important. Well, you don't want to just cut it, right? And then not have it. So it's when you go to do the next chunk, you get the previous 200. So you have that overlap between them so you don't lose out on your context. So this thing runs through this entire process, and I will have this for you, by the way, that you can download. Runs through, and it basically what this thing does is it stores this stuff, right? It's storing this stuff in our database for us, plain and simple. So if we were to go into these 2 indexes that we have, we can see that it's just storing all of our information in there. Pretty cool. So now that it's in there, what do we do with it? Well, now that it's in there, we need to have a conversation with it. So like I showed you earlier, we're able to kind of go back and forth. It asks us some follow-up questions, and then it goes out and it answers our question. So again, just to demonstrate this, if I was to come through here and say, do a new session, and let's say I was to come through here and I was to say, I'm struggling with my sales. I keep messing up my discovery. I feel like I should quit. Okay, goes out, says, hey, I understand that you're frustrated. Can you give a specific example? I had a SaaS founder on my call. I went straight into a demo without really discovering his current pain points. Would have been a great deal for me to close. I don't think I'm cut out for sales. Okay, so just like saying what our problem was. Now, what we're going to do is we're going to look at what's going on in this. So the thing that's cool about n8n is it's going to show us the flow of logs of what is happening at each stage. And so let me actually go through first and show you what each of these things is doing, and then we'll go back and look at what that looks like at each stage. First things first, every n8n workflow needs a trigger. So our trigger is the chat message. Anytime we send a message, whether it's the first message, second message, 20 millionth message, it triggers here and it sends it into this bot that we have. So what does this bot do? Let's open it up. Or actually, let's talk about it first on a high level. So the first thing that the bot needs to have, or an agent in this case, this is technically an n8n agent, meaning it has a lot of tools that it can use to do different things, and we're telling it how to use those tools. So first thing, every agent needs to have a chat model that's powering it, okay? So we can see chat model has a little asterisk saying you need to have it. So our chat model in this case, we're telling it, hey, use GPT-4 Mini. Again, you're going to connect your OpenAI account, which I'm not going to show you how to do because it's pretty simple. But we're saying, hey, anytime you process something, you need to use GPT-4o Mini. Cool. Then we have this optional memory node. So this is not actually mandatory, but if you're going to have a conversation, you want it to be there. And the reason for that is we're telling it to remember our conversation. Now, this context window length is saying how many messages should I pull? So what that means is anytime this thing goes out and does its thing and goes to ask our Pinecone database to send back its stuff, and then it sends it back to OpenAI to process all the information, it's also sending or using the past 10 messages as part of its response. So it knows if I asked it 3 questions earlier about something else, it's going to take that into account with its overall context that it has about what you're asking it. So it has memory. And again, we don't care if this like persists when we close the browser and go away. We don't care if it's still there. So that's why we're using a window buffer memory. If you wanted to actually like store these conversations somewhere, you would need to connect it to like a different type of database, which you can do, but again, not the point of this video. So we have our chat model, we have our memory, and then we have a few different tools because they're doing different things. So we have one tool that can retrieve for us philosophical insights. We have one tool that can retrieve mental models, ways to think about that problem and ways to solve that problem. This one, the philosophy retriever, what it does is it goes out to our Pinecone account, and the philosophy one goes to the Socrabot index, okay, which is right here, Socrabot, and it basically passes the question. So the query that was passed to it, sales disappointment and learning from mistakes. So again, let's think about this, because right, we didn't actually type that in anywhere, but it's being passed through. Why is that happening? This is what the agent is doing, okay? The agent in this O1 model. The reason that it's doing that is it's trying to make sure it sends the most relevant piece of information over to our Pinecone database to pull the best information back. So it's saying, hey, sales disappointment and learning from mistakes. So especially this piece, learning from mistakes, it's going to go out into Pinecone and find all of the different philosophy books we trained it on that talk about mistakes, learning from mistakes, failures, all of that type of stuff. It's going to pull the most relevant piece out. So again, we're telling it, hey, connect to my account. You can leave this as standard. You're retrieving documents as a tool for an AI agent. And then you're telling it just like the name of how it should refer to these things and what a description of this tool is. So we're saying, hey, use this tool when you want to know something about philosophy. This is the tool to go see if it has any answers for you. Then we do the same thing for the mental model retriever. Only difference is it's going out to this index instead of this one. All right, so this one has all my philosophy books. This one has all my mental model books. I could have a third one down here where I scrape my favorite influencers' Instagram and I transcribe every video that they've ever done and put it in there, right? Maybe, for example, if you're really into Stoicism, you follow Ryan Holiday, you go scrape everything he's ever said on Instagram and pull a transcript and train the transcript into your own database for your own use, of course. So telling it the same thing, hey, mental models are ways of thinking about problems. This tool is trained on popular mental models. So we're kind of telling it like, hey, go use these when you need to get that thing. So if this agent decides that it needs a mental model, it knows it has a tool that is responsible for giving it back mental models. And then you'll notice each of these have an embedding in there. So similar to over here, where we needed to insert our documents with an embedding, we need to retrieve our documents with an embedding. So if we think again back to the math, we're telling it how to take this query and translate it into a bunch of numbers. You don't need to know about what this is at this stage of your journey, at least if you're watching this video. You know, it's like, I mean, cool if you took advanced math in college and linear algebra and transformations and all that type of stuff, that's cool. Like you might know, but it doesn't matter if that's not you. All you need to know is this needs to match. So you use the same model to retrieve the embedding as you did to create the embedding. Now let's look at the elephant in the room, which is what is this bot actually, what are we telling it? Okay, so it's a tool agent, and then we're telling it, hey, we're gonna define the prompt below for you to use. Let's look at the prompt. You are a personal philosophy companion. You help people solve their problems by referencing their personal mastermind of mentors. When a user sends you a query, you should do your best to understand the meaning behind their question instead of pure keyword matching their question. I probably don't need this part in here, to be honest. This is kind of what the vector database does, but it's fine. If the user question is too surface level, ask them for a real world example. Then when you respond to them, give them practical advice framed from that example. The reason I put this in here is I didn't want it to be like, hey, if I'm struggling with my sales, that's not really enough to go off of, right? And so it's like, hey, if you don't have a detailed example, go ask them until you're satisfied with that. From there, use your tools. Then we tell it what its tools are. You have the philosophy retriever, used to find specific context that might have insights into the user's question based on popular philosophers. And then we have mental model retriever, used to find specific ways of thinking about a problem. So when answering questions, you always answer with a few different ways to think about it from the philosophy retriever and a few different ways to think about it from the mental model retriever. You don't have to have this, by the way. I put this in here because I wanted it to specifically answer with some from each category. And then we say, last but not least, here's the user's question. So let's look at how that actually all breaks down though in the code. So like I said, we have our window buffer, which is it remembering things we've talked about before. Let's look at the first prompt. So boom, this is what we just went through, right? Your personal philosophy companion, that blah, 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 blah. And then it has the user question in here. I'm struggling with my sales. I keep messing up my sub-really. I feel like I should quit. AI says, I understand you're feeling frustrated. Blah, 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 blah. So it has the question in there, has the context in there, and then it has the specific example, right? Because we're having this back and forth conversation. And so this is where that memory buffer comes into play. So AI has this, right? It goes out, it knows that this is what it's got to deal with. It's like, okay, I have all of this stuff, all of this context. What tools do I have at my disposal? It goes out and hits this philosophy retriever, which is right here. Goes out, hits here, and it says, sales disappointment and learning from mistakes. Okay. The Pinecone database goes and does its thing, and it responds to us all of these different chunks of text from our book. So some of these might be super relevant. Some may be a little bit less so. I told it to reply to me up to 10 different chunks. And so it's giving me 10 different passages from all of the information that I've trained it on. So again, across all three of these books, what are the 10 most relevant chunks of information that it's gotten? If you wanted to look at the actual output, this is what it means in math parlance, right? It's all just strings of numbers that mean stuff. Goes out and does the same thing for the mental model retriever, sales process and discovery. So it actually gave it a slightly different question for the mental model retriever. Got a bunch of responses back, and now we can see asked it a few different things. Sales process and discovery, self-efficacy in sales. Probably didn't like any of those responses because it went back out to the mental model retriever again. Okay, so it's going out. Now it's pulling context about, okay, well, here's stuff about shoemakers and physicians and what they feel about certain things and blah, 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 right? All of that type of stuff. Takes all of those responses, passes it all back to OpenAI, okay? So it passes it back to this chat model over here. Went over here, grabbed all the stuff it needed, This agent orchestrated, is like, okay, I got all the stuff. I think this is sufficient. Boom. Sends it back to OpenAI and says, now go answer the user's question based on all of this text we just pulled. Okay? These are all chunks from some mental model stuff, from some philosophy stuff, pulling all of this relevant information, all of these pieces of text from all of those books. Okay? And then popping back our response, which in this case, again, here's what Stoics might have said. Here's how you can think of this instead of as a problem, as like growth oriented. This is not a failure of yours. This is an opportunity for you to become a better salesperson because now you know the importance of the discovery. So see this as a stepping stone towards you becoming a badass. First principles thinking. And this is what I actually went through in the example I gave earlier with the salesperson on my team. Let's break your process down into the fundamental components. What would it mean to do a perfect discovery? Boom. And you can go through and continue to dial yourself in. And then again, it gives you some practical advice. So that's it. I hope you liked this video because, again, this is the type of stuff that I think is really awesome. For a very long time, a lot of this AI stuff and the advances are stuck in like the business to business space, which is cool. It's cool to be able to sell this stuff to businesses. But I think there's this huge gap where you have everyday humans that could really benefit from these tools. And this is a really concrete example of something like that. So I hope you take this. I hope you apply it in a way that's meaningful to you. That being said, see you in the next video.